Hi guys, welcome to Cola Teaches Math. So today I wanted to do a video on the accumulation function. I don't have my calculator on me, but we're going to chat about it. So here we go. So the accumulation function, I like to teach it like this in class, which your teachers probably do as well. It's just a rearrangement of the fundamental theorem. So we're going to have f of b equals f of a plus the integral from a to b of lowercase f of x dx. And this is going to usually be whatever function they give us. So this is going to be the given function, which is going to be the derivative. So dy dx. Now, what I like to say in my class is what I want equals what I'm given plus the integral between the two of them of the given derivative. Okay? So we're going to use that for this particular question right here. So a tank starts with 100 milliliters of water. At time 0, the volume of the tank is changing at a rate of dv dt equals this function. They want me to find v of 3. All right, so let's do it. Let's set it up exactly how I just said. What I want equals what I'm given. I'm given the initial volume at time 0 plus the integral between the two of them. Now, take note here. Do you see how this is a and the lower limit's a? So if this is 0, the lower bound is going to be 0. The upper bound is going to be this number right here. I'll color code it. I'll highlight it right there. And then we're going to integrate dv dt. We're going to do this straight in our calculator. My advice to you is to type dv dt in y1. And you're going to go ahead and integrate that in your calculator. So we're just going to go through the setup right now because I don't have my calculator and I don't feel like getting it. All right, next one. The cost of a certain piece of machinery is $700. So that looks like that is the starting amount. So I'm going to set it up like this. I always like to do my initial condition, v of 0 equals 700. Why v? Because that's the variable they use. Its value is depreciating with time according to dv dt equals this, where v is dollars. $v is its value 2 years after purchase. What's the value 3 years after purchase? So they want v of 3. I like to set it up like this. So what I want equals what I'm given plus the integral between the two of them of the derivative, dv dt. So in your calculator, once again, you'd put this in y1, and you would just do 700 plus the integral from 0 to 3 y1 dx. And that's going to give you the final value, which obviously should be less than 700 because we're depreciating. And last one, the water tank holds 1,500 gallons of water at time 0. That's my starting amount. Water's pumped into the tank at this rate. To the nearest whole number, how many gallons of water in the tank at time 20? Okay, so what do we know? We know E of 0 at time 0 is 1,500. That's what we start with. I want E of 20. What I want equals what I'm given plus the integral between the two of them of E of t, because that's how they name their rate right now. So in your calculator, you would do 1,500 plus 0 to 20 of what you have in y1, because you always put the function in y1. Okay? So the accumulation function, what I want equals what I'm given plus the integral between the two of them.